In this video, we're going to see the difference between single displacement reactions and double displacement reactions. Single displacement reactions is where you have one element that's alone reacting with a compound. That one element will kick out an element from the compound, and they'll switch spots. So in this situation here, A kicked B out. So B is alone now, and now A is with C. So A plus BC gives you AC plus B. You could also have it the other way around, where you have D kicks C out, and then C's alone, and then B and D are together in a compound. So for example, over here we have copper plus silver nitrate. Copper kicked silver out, so now silver's alone, and copper is in a compound with nitrate. So a single displacement, somebody is single in the end. It's just someone different. So you have something single and a compound at the end. You start off with something single and a compound. The one that's single kicks somebody out of the compound, and now somebody new is single. A double displacement also involves a switch, but instead of having something single reacting with a compound, it's two compounds reacting together, and the two elements at the front switch spots. So at the end, you still have couples, two sets of dance partners. It's just they swapped. So A was dancing with B, C was dancing with D, and now it's the other way around. A is with D, C is with B. It's called double displacement reaction. So here we have silver nitrate and potassium chromate. The silver swaps spots with potassium. So now silver was with nitrate and it's now with chromate. Potassium was with chromate and is now with nitrate. So that's called a double displacement reaction. So you can see your definitions here. The examples or patterns are here. And these are specific examples with some visuals shown. You can see double displacements oftentimes will produce a precipitate. Here you can see a really cool reaction. It's actually this one here, where silver is being produced on the copper wire that's placed into the silver nitrate solution. So you're going to try to classify these as single or double displacement reactions. Pause the video, try it yourself, and then classify them. So unpause, and now you can check your work. You can see here you have two compounds, and they've switched partners. The Li is with Cl now, the Na is with F now, so that's a double displacement, DD. Here again, two compounds, and they've swapped partners. Calcium is with OH now, sodium is with Cl now, so they switch partners, so once again a double displacement. Here you'll notice you have a metal and a compound, so something is single. It switched spots with the H, so now the H is alone and the Mg is in the compound, so that was a displacement, but somebody's single, so it's a single displacement. Very similar here, somebody's single with a compound, now Li is no longer single, but H is, so that was a single displacement. Here once again, something single reacting with a compound, something new is single, single displacement. Here two compounds reacting, we simply switch partners. Barium is with nitrate now, silver is with chlorine now, so that's a double displacement. This is a similar exercise, just with words instead. It's the same approach. You have an element reacting with a compound. The sodium kicked the one element out of the compound. Now copper's alone and sodium's in the compound, so we have a single displacement because somebody is left alone. Here you have two compounds, barium hydroxide and zinc nitrate. They switch partners. Zinc is with hydroxide now, barium is with nitrate now, so that's a double displacement. Here you have a single element reacting with a compound. The element kicks one element out of the compound, a new element's alone, and that element that was alone before, zinc, is now in the compound. So we have a single displacement reaction. Here, similar pattern, single displacement reaction. Here, two compounds with the partners switching spots. Potassium goes with fluoride now, lithium with chloride, so no one's single in the end, so we have a double displacement. And then finally here, we have element with compound, with a new element being single at the end, and new compound with new partners, so we have single displacement reaction. And just like in the previous video with the word equations and skeleton equations, balance equations, and identifying, you have similar problems to try here. So here we have, we'll do a word equation. Sodium is reacting with calcium chloride. To make calcium plus sodium chloride. From the word equation, you can probably already tell that sodium was alone, now calcium is alone, so they switch spots. So you can tell this is a single displacement reaction. If you want to write a balanced equation, you have sodium reacting with crisscross with calcium chloride, producing now calcium's alone. No states are given to you here, so it's okay if you don't write any right now. Crisscross sodium chloride. You'll see we need 2 chlorines, so we'll put a 2 here. Now we need 2 sodiums, and then we can leave 1 and 1 there, so it's balanced. And so these are pretty straightforward ones to balance for the most part. Try the next one on your own, and then unpause the video and check. So it looks like you have aluminum chloride, reacting with sodium iodide. So right away you can probably tell what it's going to be because we have 2 compounds reacting. They're going to produce aluminum iodide, so aluminum switch spots. Plus sodium chloride, so did sodium. So no one's alone. Dance partners are switch spots, so that's our double displacement reaction. You can do a balanced equation. We have aluminum chloride with our crisscross, plus sodium iodide with our crisscross, NaI, produces aluminum iodide with our crisscross, AlI3, plus sodium chloride with our crisscross, NaCl. To balance, it looks like we'll need a 3 here to get 3 iodines. Now we have 3 sodiums, so a 3 here to get 3 sodiums and 3 chlorines. It looks like now we are balanced. So that was a fairly straightforward one to balance as well. And this one here, lastly, is the other way around. You have a skeleton equation, you got to convert it to a word equation, then to a balanced equation. For word equation, it's pretty straightforward. It looks like you just have magnesium. It's reacting with NaCl, which is sodium chloride, so using our ionic naming rules here. And it's going to produce sodium. So sodium was kicked out and now is alone, something is single, plus some magnesium chloride. So because something is single, we can tell this is a single displacement reaction. To balance it, let's see, we have Mg plus NaCl produces Na plus MgCl2. Pretty straightforward one to balance too. It looks like we just need 2 chlorines, so we can put a 2 there. It means we need 2 sodiums now, and now everything looks balanced. So 1, 2, 2, 1, if you wrote it in that order. And so in this video, we saw how to identify single and double displacement reactions. We learned how to identify them just if they were written out. We learned how to write word and scale and balanced equations, and then identify the type from those as well. So all this is simply skills you've practiced before. The only new thing is really just classifying reactions now, the type of chemical reaction as either synthesis, decomposition, single displacement, or double displacement reactions.